we are going to do this Pentagonal Prism first problem, okay, in a solid software. How to do it, we are going to learn. So first position is in square of dimension 35. So thickness it is 0.50. Okay. So after this, we have to draw the diagonal lines to find out the center of the axis. Okay. So these lines has to be thin lines in case of prism. So we can dimension, mark the namings. Top face notation A, B, C, D, and the bottom face notations are A1, visible, B1, visible, C1, visible, D1, visible, and we have center of the axis, that is O. So we have O1. Okay. So now projecting the lines, so we can draw the front view. So here axis length how much? It is 65. So I will take 65 axis length. Third line it is the axis length. So take 0.50 only here. So here 65. Also 65. So now we can write front view notations. A dash, C dash visible, but A dash, similarly, you can see B1 dash, the center O1 dash. And now the second position. So copy this. Go to move, create a copy, then drag it along the line. So now see angle of inclination here, it is 45 degrees. So we will go for the base edge inclination, that is 90 minus 45, it is again 45. So the same procedure, base edge inclination, we have to go here. Okay. First this, second this, and give the angle 45. Now we can see, we can extend this axis and find out angle. Exactly 45. So that's how we are going to do. Okay. Now we will project it downward. For the bottom face notations, you can write first A1, B1, C1, B1. This is O1. Similarly, we have this. It is B, C, D, and this is O. Okay. So herein, so we are not able to see this D1 and this D1 and C1. So that D1 and C1, it is written within bracket. Okay. Now the procedure for writing second position top view is, so first we have to draw an outer boundary line So you follow the same procedure how we did in sketchbook. Starting from A1, B1, next to B1 to C, okay, next to C to D, then D to E. So that's an output line. Now visible face. This square face visible from the top view. Okay, that is ABCD is visible. Okay. Then this B dash, E dash, and B1 dash, A1 dash also visible already in rectangle. So this bottom face not visible from the top view. So we can write part of it with the dashed line. Okay, then finally we have an axis. So we can show the axis from A1 to O. So you see in this the angle of inclination, that is 30 degree. So 30-degree angle line we have to draw here. Okay. So now we copy this. So we have to place it with respect to this resting edge. So we take it to this D1 point, and this is your project. So we will be projecting, say first we will be top face this, and this top face will write the notations. Okay. So it will be ending here. B, so that B also ending here. This is C. You can just touch this C point and then okay. So the notation here it is A dash. This point it is B dash. This is C dash. This point it is D dash, and this is O dash. So now similarly we will write for the bottom face. Okay, so this bottom face and this bottom face we will write. First one it is A1. So A1 it is extended till here, A1 dash. So these 2 points are merging here. Similarly B1, so here exactly we get it. Next to D1. D1 it is on the XY line. And similarly we have C1. C1 also here till XY. Okay. Now finally we have O1. O1 till here. Okay. So now we have to write down the notation for it. So this quantity is B1 dash. Dash. B1 dash. Okay, now we have to write. Take the nearest point here. The nearest point of the XY line it is D. So right here. Point to D. Okay. Is with A, C, D1. So these are fine. So first we will construct the dashed lines. So dashed line from D to C, D to A, and D to D1. That is from D dash to A dash, D dash to D dash, D dash to C dash, D dash to A dash, and D dash to D1 dash. Okay. Now let's think it is written with a continuous line. Okay. Now vertical edges from A dash to A1, C dash to C1, then B dash to B1. Like this, then finally we have axis from O1 dash to O dash. Okay. See this? Okay. Extra lines were there. We are going to trim it. Yes. So here, second position, angle of inclination, it is base edge inclination. This inclination is base edge inclination equals 90 degree minus angle of inclination to HP, it is 45. So equals it is 45 degree. So that's what the base edge inclination in this second position front view. Okay, this is how we complete the problem. Okay. Okay, today we are going to do pentagonal prism problem with respect to bit angle. Okay, how to do it in solid edge software. I will show this problem we are going to do. So this is a straight line. Okay, so we have to construct a pentagon here with respect to edge on the right hand side. Make sure this icon has to be on. Maintain a relationship. This icon has to be on. To use a polygon by center. Okay. So can give the namings A. Top face center A, B, C, D, E. Similarly, we have bottom face center A1. C1. Yes. So to find out the center of the axis, so we'll be drawing thin lines. Okay, the perpendicular bisectors we have to draw. Okay, at least 3 perpendicular bisectors we have to draw here. Okay. So 3 perpendicular bisectors drawn. This point is O1. So by projecting the lines, axis length it is 60. So first axis 16. Notations we have to write that is E dash, B dash, C dash, D dash, bracket, D dash and bracket. Similarly, for the bottom face also we can write A1 dash visible here, B1 dash visible, C1 dash visible, B1 dash not visible. Similarly, here we have B1 dash also not visible. So now we have to go for base edge inclination. So angle of inclination to axis here 45. So we will go to base edge inclination. Yes. 90 plus 40 equals 50 degrees. So base edge. So here the inclination we have to give, that is 50 degree for the base edge inclination. Okay. Now go to rotate. Something first edge, second edge, give the angle. So angle we have to give it is 50. Again, rotate, first edge, second edge, angle. Give. So if we extend this, so here give angle of inclination it is. So we can select exactly 50 degree. Enter. So here we are getting angle exactly 40 degree. Now project it downward. Seminar on project proposal for variation. Actually, subject as mere subject so project it down these vertical lines. So from this project proposal so we have to do. So here we have A1. This point is B1. This point is C1. D1. And this point is similarly for the top face also you can write A. This is A. This is B. This is C. This is D. This point it is O. So now we know the three concept, that is writing the outer boundary line here first. Starting from this A1. Okay. A1. Next B1 to B here, then to C point. Okay, then to D, into E, into E1. Okay. So here the pentagonal face also visible, that is written with a continuous line. Okay, and this also visible at A1. Okay. So this pentagonal base not visible from the top view, so it is written with the dashed line. Okay, this rectangular face also not visible, DD1, CC1. Now there is an axis connecting from. So now, so it's a angle problem. We have to draw an angle like here. Okay, we can make this extra lines. Okay. So angle line I'm going to draw. It is 30 degree. So here the angle we have one. So we have to get 30 means how much? 120 angle line. So I think it is minus 150 minus 150 degree. So it is 30. So now it is an beta angle problem. The first arc length we have to consider, that is 60. From this reference point, first arc length is 60, and then locus line. Next, the dimension line we have from O to O1 we have to measure this distance between is 45.96. Go to our base center. Okay, a continuous line. It is how much? 45.96 meter. Okay, we will take axis line. So here we join the extend. Okay, so then find out angle 41 degree. So here also we have 41 degree. So now we have to join this. First one move. So now go to rotate, select this point and this, and place it on this axis line. Okay, now we have to project it. First we'll take a face rotations. Okay, first from D. So here D dash, D, and D dash, we get it here. Okay, similarly, this is continuous line. Next from C to C dash, we have this. Okay. E to dash, and then B to dash, and finally we have O. We can write the notations. It's easy. This point is dash. This point is dash. This is C dash. And D dash we have D dash, and E dash. This quantity is. Okay, similarly, you can write for the bottom face also. So from this D1, it is still here. Then again from C1 to, then finally from D1. So till here I will extend. Okay. Line there. We have notations. Okay, so E1 line we have to extend again because we did not get exactly. C1 dash, D1 dash, E1 dash, and finally we have this O1 dash. So now we reach the final notations. You can see that D is the nearest point. D to C, D to E, and D to B. So first we are write the dashed lines here. So dashed line from D to C dash and D to E dash and D dash to D1 dash. Everything written with a continuous line now. So here to here and then from here to here. Okay, now the vertical edges. B1 to B, then C1 to C, then from E1 to then finally we have an axis. So this is completes our problem. Okay. Today we are going to do this hexagonal prism problem with respect to appears to be. Okay. So this problem we are going to do today. Using solid software. So first we draw an XY line. Okay. So we draw XY line of thickness 0.25 mm. After that we are going to give the naming for XY line. B, Y. So we have to construct a hexagon with respect to edge here. So hexagon of dimension 25. So make sure this icon maintain relationship has to be on. Then use polygon by center, 6 sides. Okay. With respect to edge. So give the naming C, D, E, A1 in bracket. After this, we draw the thin lines to find out the center of the axis. Okay, that is diagonals we are going to draw. It is O. Okay, now here axis length is 50 mm. So you're able to see B dash, C dash, D dash in bracket. Able to see O1 dash and the O1 dash and O dash also not visible. Okay, so now 45-degree inclination to HP. So we are going for base edge inclination. t minus t5 into 45. So we have to incline this with respect to the base edge. Okay. Angle of t5 here. Then extend extend command, can extend the axis and find out the angle of inclination. A1, A1, C1. So here projection line.
Hello? Sir, is it Hello? Hello? sir, email form was there. The person came. Sir, how can we not be please approve. Please other sir, members. Sir, what are
So first we have to construct an outer boundary line. This hexagonal face is visible from here, and this rectangular face also visible. This hexagonal base not visible from the top view, so it is written with the dashed line. Here, from this slanted rectangular area is also not visible. You can show part of the line here. From here to here. Now 40-degree angle line. So angle we have to give, that is 120-degree angle. Minus
one second, thank you. Sir, actually, ನಾನು ಸ್ವಲ್ಪ ನಮ್ಮ ಇಂಟ್ರೆಸ್ಟ್
we have to have here 40-degree, 40-degree. Reference level 40. Then we have to select it. Okay. Axis line here. So select this diagram, create it. So you can take it a little lower. You can give the name. Another projection line. V1 dash, V1 dash. So here are two nearest point to X velocities E and F. Okay, E to D, E to F, and F to J, and F to F1. Like that, first we construct the dashed lines. Now rest of the diagram is written with a continuous line. The slant edges. Finally, axis.